So lesson 7 is about actually taking all the information you've found and getting it onto a graph. So we're going to look at a few examples of that. It's going to be a little more challenging than maybe some of the things you've done because it's a little less procedural and you have to understand the concept a little bit. So what we're going to do is we're going to recap asymptotes, intercepts, and holes because we have to find all of those things for each problem, but we'll probably do them pretty quickly. If you have questions, then ask in our live session this week. And then we're going to make sure we do one of these graphs in our live session because you guys are definitely going to need to practice these. So what we're going to do today is we're going to focus on the graphs that would absolutely not have an oblique asymptote, just so I can split up the notes a little bit for you guys. So when I go through and look, I know that part A would not have an oblique asymptote. I'm looking at the degree of the numerator and denominator, so that tells me that. I know part B would not have an oblique asymptote. The degree of the numerator is actually 2 because 3x would multiply x, and that would make x squared, but so is the denominator, so the degree of the numerator is still not higher. Part C could have an oblique asymptote because it has this higher degree in the numerator, so we're not going to work on that one today. And the same with part D because it has that higher degree in the numerator. And then E has the higher degree in the denominator. So we're going to look at A, B, and E today. That's going to be our focus. Okay. So remember how we talked about at the very beginning wanting to factor, if we could, each of these equations. So in part A, the numerator doesn't factor. The denominator has a greatest common factor of 2x squared. That would leave an x plus 2. So notice nothing cancels. So remember my list of info. I'm going to so I want asymptotes, holes, and intercepts. So for asymptotes, we know there's no oblique asymptote. We went through at the very beginning, and we're not even going to work with any equations that have that today. So today, we're going to write none every time there. Then it's our job to come up with the horizontal asymptote. And notice that the degree was higher in the denominator, and that means in that situation, our horizontal asymptote is at y equals 0. A vertical asymptote are values that you'd get when you set the denominator equal to 0. So my work for my vertical asymptote would be setting that denominator, 2x squared times x plus 2, equal to 0. There's 2 separate factors here that could be equal to 0. And when I solve these, I get 0 for this one. I would get that by dividing by 2 and then square rooting, and it would still say 0. And I get -2 for this one. So I have 2 vertical asymptotes at x equals 0 and at x equals -2. I have no holes because no factors canceled out at the beginning. And then I'm going to work on my intercepts. So x-intercepts and y-intercepts. This one has kind of a difficult x-intercept. You wouldn't have something that difficult on a test if our expectation is no calculators. You'll see what I'm talking about in a minute. So for the x-intercept, remember that we are setting, I'm going to erase this so you don't think the work is for the y-intercept, that we're setting y equal to 0. And then we're solving for x. And remember how we're solving for x. We're multiplying by that denominator to cancel it out. We do that on one side so that it cancels out all the factors, and then we have to do it on the other side. But the other side works out really nicely because no matter how complicated this is, when it multiplies with 0, we're just getting 0. So the next thing I would do is subtract 1 from both sides. Then divide by -2. And then square root. And remember, when you square root, you would include plus or minus. And I'm going to let you guys put this in a calculator. So this is about 0.7. So I have 2 x-intercepts. I have one at positive 0.7 and one at -0.7. Oops. And then to find the y-intercept, let's put that over here. Remember, we set x equal to 0. So if we do that in our equation here, if we take it, and you can do it in either form, whatever seems easiest for you. I get 1 over 0, which is undefined. That means there isn't any y-intercept. Okay? So here's my list of info. Now what I want you guys to do is put that info on the graph. So we're going to mark our asymptotes with dashed lines. So our vertical asymptotes here are x equals 0 and x equals -2. And then our horizontal asymptote is y equals 0. And then lastly, we have some x-intercepts that we can mark at 0.7 and -0.7. So here's the deal. I'm going to use the other graph for a minute to kind of demonstrate some stuff to you. The vertical asymptotes are breaking it up. So our graph literally has 3 parts that we have to graph. Part 1, part 2, and part 3. And we want to know what they look like, and those parts will not reach over those asymptotes and connect to each other. Don't confuse the vertical asymptotes with the horizontal asymptote. Remember, the horizontal asymptote is only here for end behavior. It's just telling me that whatever craziness happens in this graph, at the very ends of the graph, it starts to look like this horizontal line. So you can almost ignore, so I'm like literally erasing it, that asymptote for the rest of the problem except for at the very ends of the graph. Okay? Now, before I start the next part, because it's going to be something new, a little bit of analysis, I want you to understand why we're doing it. Let's say that my pencil was at a point, and don't draw this on your graph, this is just so you guys understand how we're setting up this next part. Let's say that my pen was at this point right here. How would I get, this point has some x value and a positive y value given the quadrant that it's in. If I wanted to change the y value and I wanted to see it get to a negative, one of two things would have to happen. If my graph is a continuous graph, in order to go down to the negative y's, it would have to cross the x-axis. So one option is I would have to have an x-intercept. The second option is maybe it doesn't. Then you're like, well, it's never going to be a negative y. But then the graph gets broken apart, and the next portion of the graph is down here because they're not connected, and it can be wherever they want. So that would mean that we would have to have a vertical asymptote. So the things that can make our graph change the y values from positive to negative or negative to positive would have to either be x-intercepts or vertical asymptotes. So whenever we go to try and sketch what a graph is going to look like, we're going to make ourselves a little mini version of the x-axis, and we're going to split the x-axis up with two things, vertical asymptotes and x-intercepts, because those are the two things that the y values could change. So we have a vertical asymptote at -2 on our graph, and then we have an x-intercept at -0.7, and then we have another vertical asymptote at 0, and then we have another x-intercept at +0.7. So these are all the places where the graph could stop being a positive y and switch to being a negative y. And that's what we want to test and find out. And when I say test and find out, I mean I'm literally going to take numbers in these little groups and I'm going to plug them in kind of to the factored form of our equation and see what happens. Okay, so let me go through it once and then hopefully you'll be able to see some of the stuff that happens. So let's say that first I'm testing this area. For these x's, do we have positive or do we have negative y? So I need to pick a number smaller than -2. So let's say I pick something like -10. I'm thinking about what would happen if I plug in -10. Now, if you're afraid of all the arithmetic, we're not really asking you to do all the arithmetic. We're asking you to see if it's positive or negative. So you don't actually have to do all the math if you would know. So like when I start looking at this, -10 squared would be a +100. multiplied by a -2 would be like a -200 plus 1. It's going to be a negative number, okay? So when I plug that in, I'm going to get a negative number on the top of my fraction. On the bottom of my fraction, I have a 2. That's always a positive. I then have a -10 being squared, which works out to be a positive, and a -10 plus 2, which works out to be a negative. All of these things multiplied together would make a negative, and when I have a negative divided by a negative, overall that would make a positive. So I just figured out that if you plug in an x smaller than -2, you get a positive y value. So what does that tell you guys? So I'm going to do some shading that I'm eventually going to erase, so you guys don't need to do this. This is just more for visual, so you understand what I'm trying to tell you with this little chart. So let me put back my ends of my horizontal asymptote. So what you guys just figured out is that when I plug in a number smaller than -2, I get a positive y value. That means if I try to plot any point over here, these x's give me positive y's. That means I can only sketch the graph in the area above the x-axis. So whatever I draw over here better stay here. It cannot come down here. Okay, that's not allowed. So now I'm going to test the next portion. The next portion are numbers that are between -2 and -0.7. So I'm going to try plugging in something like -1. Okay. And I'm just going to go through the same calculation again, where I'm not really calculating the values. I'm really just trying to see what it works out to be. So in the numerator, -1 squared is positive. 1 times -2 is -2, plus 1 would be a -1. So I would get a negative value in the numerator. In the denominator, 2 is positive. -1 squared is positive 1. And -1 plus 2 is positive 1. So I would have a negative value. And in the denominator, positive times positive times positive give me a positive value. And a negative times a positive would make a negative. So I'm getting negative answers here. That means for this portion, any x's you plug into the equation, you should get negative y's, which means when you go to graph this portion of the function, you should only be able to graph in this area. You can't come up here because we can't have positive y's there. Okay. All right, now I'm going to do the same thing again, and this problem is pretty difficult because number 1, the 0.7s don't make the numbers really nice to plug in, but also number 2, we are having to plug in a lot of them. This problem has a lot of different things that have changed, and so that makes it a little more difficult. So from -0.7 to 0, I'm going to pick -0.5. Okay, so -1/2 squared is a positive 1/4. -2 times a positive 1/4, if you need to write that out, will become a -1/2, and -1/2 plus 1 will be a positive. Okay, so again, I have to do a little fraction math, or you could do decimal, whatever. 2 is always positive. -0.5, but it's being squared, will turn out to be positive. And -0.5 plus 2 will turn out to be positive. So this denominator, when you multiply 3 positives together, you get a positive still, and a positive divided by a positive is positive. So here I'm getting positives. That means for every x value I plug in from -0.7 to 0, I get positive y values. That means whatever points I graph on my graph must be plotted here. So now I'm going to go on the other side of 0, and I am going to plug in positive 0.5 instead of -0.5, and I'm going to see how this would work out. Okay, I know the process is a little tedious, but if you just try to plug points into these, it gets even more tedious. So you just want these guidelines and to plug a little bit of stuff in. So 0.5 squared will make a 4th. Again, -2 times a 4th will make -1/2. Plus 1 will be a positive. 2 is a positive number. Positive 0.5 squared would be a positive number. And positive 0.5 plus 2 would be a positive number. 3 positives multiplied together will be a positive value, and a positive divided by a positive will be positive. So again, I get a positive here, telling me for all the x's from 0 to 0.7, I get positive y's. And that means the points could only be plotted here. All right, only one more to do, thank goodness, because this is long, right? We're just going to do this one example in our lesson today, and then we'll split up our future lesson, the other two, and then the last two. So now we're going to look at plugging in something that's bigger than 0.7. So let's say I decide I want to try 2. Okay. So here, start in the numerator again. 2 squared would be 4. 4 times negative 2 would be negative 8. Plus 1 would still be a negative value. In the denominator, this 2 is positive. 2 squared will be positive. 2 plus 2 will be positive. And 3 positives multiplied together will stay a positive number. A negative number divided by a positive number is negative. So I get a negative here. I didn't really calculate what it was. I just found out it was negative. And so that tells me when I plug in any number past 0.7 for x, I'm going to get negative y values. And that means as I go to sketch my graph, I can only draw points for x's past here down here where y would be a negative value, not above the x-axis where it's positive. So what we've done is we've created these yellow highlighted portions on our graph, and you would never see someone have these, but it helps you visualize what's going on. Those are allowing us to see where we can actually sketch the graph. So we're going to pay attention to a couple of things here. First, I'm going to focus on this first branch over here. What should this branch look like? So I'm going to erase the 1 and actually try to put in the graph. I know that I can't draw anything down here, and no points can be plotted down there. Now, if you guys remember, as a graph gets close to a vertical asymptote, it doesn't just like get close to the asymptote and then stop. It usually curves along the asymptote. So what that means is if there's a vertical asymptote here, as our points get close to it, they either curve and go very close towards infinity along the vertical asymptote or towards negative infinity. Since we know in this graph we cannot plot points below the x-axis, it must be going towards positive infinity. So there's kind of a guideline for my graph. And then remember out here at the ends that this horizontal asymptote is here to tell you the end behavior of your graph. Your graph is supposed to come down and look like a horizontal line at 0. So it's technically not at 0, but it should be like right above it, starting to look really horizontal. And then we're just sketching. So we're just going to complete a curve in this first section that doesn't go across the x-axis down below it, stays up here and connects these two guiding factors together. So there would be one curve. Okay. Now I'm going to go in here, and there's actually 2 portions in here because this x-intercept that splits them up. So I'm first going to start on the left side. And again, because of the asymptote, I either expect my graph to go up or down very close to that asymptote. And because I cannot plot points up here, it must be down here. And I know that I come and actually hit the x-intercept. Remember, x-intercepts are points on your graph. So I'm just going to, we're just sketching, okay? So I'm just going to connect these 2 things together. Okay. Now, because of the next highlighting, I know that when I hit this x-intercept, I crossed through the x-axis to positive y values. Okay, and I know that I'm supposed to get close to this next asymptote and either climb up next to it or down. But since I cannot plot points down in this lower region, it's going to have to be this behavior here. So again, I'm going to connect this to here. Okay, so then I've finished that second piece in the middle. I had to look at it through 2 parts to figure it out. Now I'm working on this third piece, and again, it has 2 parts because it has this intercept again that it hits. So again, next to the asymptote, I'm either going to follow it towards infinity or negative infinity. And in this case, I know it would not be negative infinity because right next to the asymptote, we were only allowed to graph positive y values. And that should stay up there all the way down to that intercept. So I'm going to connect that behavior. After the intercept, I can see that it crosses through because I can see my y values are supposed to come down here in the negative area. And then I don't have any more points to go to, okay? But again, I do have this end behavior telling me at the end of my graph, I'm supposed to kind of look like this horizontal line at 0. So I'm going to go ahead and draw this, but I'm going to make sure it curves back up and kind of looks like a horizontal line at 0. Okay. Now, yours might go down a lot further and come back up. That's fine. What I would be looking for correctness on your graph is if your curves are in the same area as mine and that you cross the x-axis at the right spots and you have the right asymptotes. Okay. So the last thing I want you to do with this graph is I want you to state the domain and the range. So for the domain, remember that's x's, we did actually skip 2 x values. Our graph got broken apart at both of these asymptotes. So the easiest way for us to say that here is to say what x cannot be. So we're assuming that we know x can be all real numbers except for. So you can either write x is all real numbers except, or I will accept the notation that just says x is not equal to, and here we would list -2 and 0. Okay. For the range, my piece of advice to you, and I'm going to erase this, if you struggle because the graph is in a lot of pieces, is that I would make myself a little y-axis over here, and I would look at each piece. So when I look at this first piece of the graph, that curve didn't quite hit 0. So it came all the way down but didn't quite hit 0 and was graphed above 0. So its range would be x is greater than 0. But then the second piece had negative y values and all the positive y values. So it had all real numbers. And then this third piece came down to about -2. So it had -2 and above. But notice that by the time I finished this, the whole number line for y was covered. So my range in this case would be all real numbers. Okay. So you're going to watch another video tomorrow for the next 2 graphs. They have a little less parts, so they're a little less complicated. And then you'll watch a third video this week when the asymptote is not horizontal. So no homework for this tonight, not until the next lesson.